Hi, I am Anshpat from Department of Mathematics, IIT Guwahati. This is my CS343 OS presentation, and the topic is file management in Windows XP. So here we start. Before we begin, these are the basic topics in Windows XP that we'll be covering. The first is the directory structure. Each operating system has its own directory structure. The directory structure used in Windows XP is the tree structure. We'll look at it later. The different file systems supported in Windows XP. There are three basic file systems supported. The file sharing and file permissions in Windows XP, and the Windows File Protection System. Windows File Protection System was one of its kind protection system which was started with Windows 2000 and Windows XP. So we'll look at that. So starting with the directory structure, the directory structure in Windows XP is basically the pre-directory structure. It is the most common directory structure found in any of the operating systems. The tree directory structure is such that each entry in the under a directory is either a file or a subdirectory. How this works is basically initially we had a single layer directory which had its own issues. We moved on to the two-layer directory which had a root directory within which it had subdirectories, and then we could store the files. In a tree directory structure, it is more of a generalization of the two-level directory structure. We can have n number of levels, and as you can see on the screen, this is how a tree directory structure looks. The advantages of a tree directory structure are the searching for any file becomes very easy. We have it's the file's absolute path, its relative path. We can look for it using either of them. Absolute path starts at the root, while the relative is like relative to which directory you are in. Besides these advantages, a tree directory structure also has its own disadvantages, one of which being that the accessing of file becomes very inefficient, because you could be in, say, directory 1 and in subdirectory 1, while the file can be stored in subdirectory 2 under a series of other subdirectories. So the accessing of files becomes very inefficient in our tree directory structure. File systems in Windows XP. So majority of the file management is done by the file system. So Windows XP supports three basic file systems: the FAT in its two forms, FAT 16 and 32, and NTFS. FAT stands for the file allocation table, and it had three major variants when it came out. It was FAT 12, FAT 16, and FAT 32. So the 12, 16, and 32 denote the number of bits used in the table entries. What the file allocation table does, it stores each file as a linked list of the locations at which the locations of the clusters of disk area where each file is stored. So the say some file a.txt, it starts at cluster 1, and at the end of cluster 1 it goes to say cluster 3. So from 1 to the linked list will be from a.txt pointing to 1, pointing to 3, pointing to say 21, and it can come back to 7. The FAT stores the whole thing as a linked list, and we need to access the disk storage on our own. So from 1 we go to the first cluster and so on. NTFS is kind of an improvement over the FAT. NTFS stands for NT file system, and it came out with the Windows NT operating system. It is sometimes also referred to as the new technology file system. It is the default file system in Windows XP, and Windows also recommends NTFS to be used in XP. In place of FAT, what we kind of use is the master file table, which stores a lot of metadata, and in case of small files, it stores the whole files in the table itself. There are some important features of NTFS include file compression and sparse files. Sparse files are things like, basically, think of sparse matrices. The whole matrix need not have non-zero entries everywhere. So we do not need to store the entries which are zero, because when we don't store them, we know that they are going to be zero. So that also saves a lot of storage space for us. So NTFS basically had file compression, sparse files. There are a lot of things like disk quotas and journaling, but these are two major features in NTFS. So when we talk about a file system, what is important is the disk structure or the partition structure that the file system follows. So in NTFS, in a partition that is formatted with the NTFS file system, the first 16 sectors of the partition are reserved for the partition boot sector or the metadata. required for booting. So in the first sector, it has the bootstrap code, while the next 15 sectors are basically the program loaders of all different kinds. Also, the bootstrap code is copied into the last sector of the whole partition, so that in case of loss of data or say due to any error the bootstrap code is lost, then it can be copied back to the first sector and the process could continue without any issues. So what you see here is basically the structure of the bootstrap code. We have jump instructions and BPD, extended BPD, the actual bootstrap code, and the end of sector marker. Yeah. The next important thing in NTFS is the master file table. This is like a defining feature of NTFS. It records each file in the NTFS volume. It records itself within the table. The first record actually is reserved for the master file table itself, while the second record stores a mirror of the MFT. The mirror of the MFT and the MFT, they're basically, their locations are stored in the boot sector itself. Why? And the mirror of the MFT is required in case of loss of data in MFT or something like that, so that we say the first few entries of MFT get corrupted, we can refer to the mirror of the master file table, and from there we could like copy back those images so that the crucial files, the data regarding the crucial files in the MFT is not lost. The master file table, as you can see, stores all kinds of meta file data corresponding to each record. It stores the file name, the creation date, the access permissions, the size, it stores everything. In case of smaller files, it also stores the whole file data itself. So accessing the file becomes very easier and faster through a master file table, because as compared to FATs, in FATs we get the linked list of each data location and we need to go to the location and extract the data. But in case of master file table, we have the file data stored in the table itself from where we can access it in case of smaller files. File allocation in NTFS. So how does NTFS allocate the files? Does it allocate contiguous disk space or in fragmented spaces or something like that? So NTFS tries to allocate the files in contiguous fragments in a single fragment. That obviously requires a fragment size available which is larger than or equal to the file size in itself. If that is not available, okay, first of all, we need to know the file size beforehand if we want to allocate it contiguously. If we do not know the file size, then we cannot find a fragment which is larger than the file size. So if we know the file size beforehand, NTFS tries to allocate it in a single fragment. If no such fragment is available, then NTFS follows a descending order of fragment sizes, starting from the largest fragment and then going down to whatever number of fragments are required. So yeah, and if the file size is not known beforehand, then NTFS works pretty similar to FAT32, in which case it allocates the first sector, which is first cluster, which is available, and it allocates that to the file. If more are required, it will move in order of the available clusters. Since we need to allocate clusters, free space management is very important, because to know which clusters are free and which are actually used is important. Otherwise, we can overwrite on file data which was already stored, and that will result in loss of file data. So basically, free space management in NTFS is done using a meta file known as bitmap. What bitmap does, it denotes each cluster in the partition by a bit. If the cluster is used, it denotes it by a 1. If the cluster is unused, it denotes it by a 0. So in this case, we have a whole description of each cluster represented as a bit, obviously. When a new file is allocated or an existing file is deleted, the bitmap needs to be appropriately updated, and that is handled by the OS. So what we see here is a representation of the bitmap, and each element here, like the first one is 46. So that is obviously in the hexadecimal representation, and that denotes 1 byte of data. So 46 is basically 01000110. So 0100 means that the first cluster is unused, the second is used, the third and fourth are unused, and so on. So these represent basically 1 byte of data. It is each of these is stored using 1 byte of data and represent 8 clusters uh, corresponding to each byte. Yeah. Now what is important is basically file permissions in Windows XP. So any file in Windows XP can be given explicit permissions as to who can access the files and who cannot. And in what way can you modify the file? Can you just read it? Can you execute it? What are the different permissions that can be given to each user or a group or the root user in Windows XP? So this screenshot here is for uh, 4-part harmony.doc. That is the name of the file. And in the properties section, we can modify the permissions for the file if we are the creator of the file. So here there are all the groups or the username. So all of these are the groups which are like the TAs, the students, the instructors, while the first one is a single user. So when we select the user, we can modify the permissions over here, the various kinds of permission. Are we giving him full control? Can the person modify, read and execute, read, write, or there are the special permissions which require advanced settings. So yeah, there is an option to allow certain things and to deny certain things. Why are there both allow and deny options? Shouldn't one suffice? That is because we could be allotting permissions to either a user directly or to a group of users, and a user could be part of two different groups. Maybe we need to give certain group of people full control, but a particular user in that group needs to be denied full control. So all of that can be handled using both the allow and the deny parameters. The deny parameter takes precedence over the allow one. So say Jana over here, the user which is selected, can be a part of, say, the instructors group. However, we do not want Jana to have full control because the instructors probably have full control of the file. So we can just click deny over here, and that would take precedence over the allow parameter in the group permissions. Now we come to Windows File Protection System. Windows File Protection System was, as I mentioned, one of the new parameters that came up in Windows 2000 and Windows XP. It is a subsystem included in them. It prevents programs from unknowingly or from mistakenly replacing critical Windows system files. It covers all the files which the operating system installs by itself, such as the DLL, exe, sys, OSEX, all such kinds of files. It maintains a cache folder where it stores the backup copies of these files. And any changes made in these files, whether they are replaced, they are deleted, or just maybe modified using any unauthorized methods, are reverted. The files are replaced from cache. And if the file is not available in cache, the OS will search the network path or prompt the user to reinsert the Windows installation disk. And from there, the backup copies of the files will be placed back over there. Newer versions of Windows OS abandons use of WFP and instead uses access control lists, which are basically like the permissions which we saw earlier. It has a list of permissions and who gets what permission, which methods, which processes, which domains can delete or say modify, read critical files. That's what is used in newer versions of Windows OS from Windows Vista and Windows 8 onwards. Thank you. That is it about the Windows XP file management.